Good morning everyone. Today we will be solving few questions on matrices. So let us move on to the first question. I'll be just reading out the first question here. If A dash is -2, 3, 1, 2 and B is -1, 0, 1, 2, then the value of A plus 2B the whole dash is. So in this question, we are supposed to find the value of A plus 2B dash. See, basically we know that A dash represents the transpose of matrix A. So transpose of matrix is given. Now what do you mean by transpose? A transpose is something that we get by interchanging the rows and columns of a matrix. So A dash is given here. First let us write the value of A using A dash. So A will be -2, 1, 3, 2. Now we are also given with matrix B, but we want 2B. So we will be able to get 2B by multiplying each and every element of matrix B with a scalar 2. So 2B will be equal to -2, 0, 2 and 4. So we need A plus 2B first. So A plus 2B will be equal to, see, for adding the matrices, the order of both the matrices should be same. So even here, we'll be able to add these two matrices. So -2, -2, 1 plus 0, 3 plus 2, 2 plus 4. We will be adding corresponding elements to get the sum of two matrices. So here it will be -4, 1, 3 plus 2 is 5, 2 plus 4 is 6. Now this is the value of A plus 2B. But what we need from the question is A plus 2B the whole dash. That is the transpose of matrix A plus 2B. So if I want to find the transpose of matrix A plus 2B, I should be interchanging the rows of this matrix as columns and columns as rows. So what do we get is -4, 5, 1 and 6. So this is the required value of A plus 2B dash. Now let us move on to the second question. Now in the second question it is given that if A is equal to 3, 1, 0, 1, then A dash is, we are supposed to find whether A is what kind of matrix. So here the options given are asymmetric, skew symmetric, orthogonal or none of this. So first we will be finding the value of A dash and then see what kind of matrix A is. Now if I can see, already we are given with matrix A. So I'll be able to write A dash as, see, A dash is a transpose of matrix A. So I'll be getting A dash by replacing or interchanging rows with columns and columns with rows. So I'll be able to write A dash as 0, 3, 0, 1, 1. So what is the next thing that we are supposed to do? We should multiply matrix A with A dash. So A dash will be equal to 3, 1, 0, 1 multiplied with 3, 0, 1, 1. So for multiplying two matrices, the number of columns of a first matrix should be equal to the number of rows of the second matrix. So here I'll be able to multiply this as, see, first we will be considering the first row and first column so that we get the first element. So 3 into 3, 9 plus 1 into 1 gives us 1. Then I'll be considering the first row and the second column. So that becomes 3 into 0 plus 1 into 1. Then the second row, first column, 3 into 0 plus 1 into 1. Then the fourth element we will be getting by multiplying the second row with second column. So 0 plus 1. So this will be equal to 10, 1, 1 and 1. Now if we observe A dash, see, we should tell whether this matrix is symmetric, skew symmetric, orthogonal or none of this. So if I want to tell this matrix is symmetric, even if I take a transpose of this matrix, I should be getting the same. So let us first take the transpose of A dash. So if I take a transpose of A dash, what do I get? This is 10, 1, 1 and 1. Now this is again equal to A dash. Now first of all, what do we mean by a symmetric matrix? See, for a matrix to be symmetric, or for if we should tell a matrix is a symmetric matrix, A transpose should be equal to A. So even here we got A dash the whole dash is equal to A dash. So we can confirm that A dash as a symmetric matrix is a symmetric matrix. Why? Because the transpose of this matrix is equal to the matrix itself. Now the third question is, for every matrix or for every square matrix A dash minus A dash A is. So the given options are a symmetric matrix, skew symmetric matrix, null matrix, none of these. So we need to tell whether A dash minus A dash A is what kind of matrix. See, the first thing is, if we had elements, we would have taken the transpose of it and we would have found out what kind of matrix it is. So even here we will be taking the transpose of this whole expression. So first thing, I'll be writing the expression as it is, A dash minus A dash A, and I'll be considering the transpose of whole expression. Now we already know A minus B the whole dash can be written as A dash minus B dash. So I'll be applying the same thing even here. So A dash the whole dash minus A dash A the whole dash. Now even this and this are of the form AB dash. That is, I'll be able to write AB dash as B dash into A dash. So if I apply the same thing here, I'll be able to get this as A dash the whole dash multiplied with A dash minus A dash multiplied with A dash whole dash. So we already know that A dash the whole dash will be equal to A. So I'll be able to replace this A dash whole dash with A dash as it is minus A dash. Again A dash the whole dash can be written as A itself. Now if I compare LHS with the RHS, this is A dash minus A dash A the whole dash. Since we are able to get something like A dash is equal to A, that is A transpose is equal to A, this matrix, whatever we get by multiplying this and subtracting this, will also be a symmetric matrix. So here A dash minus A dash A is a symmetric matrix. Now let us move on to the next question. If A and B are symmetric matrices, then ABA is. So even here the options are given. We should tell whether ABA is a symmetric matrix, skew symmetric, diagonal or a scalar matrix. So first thing is, since symmetric, skew symmetric is given, we will be considering the transpose of ABA. So what do I get? ABA the whole dash we are supposed to find. See, if we have something like ABC the whole dash, I'll be able to write this as C dash B dash multiplied with A dash. So I'll be applying the same result even here. So AB A dash can be written as A dash B dash multiplied with A dash. Also, they have already given us that A and B are symmetric matrices. So I can replace A dash with A, B dash with B, again A dash with A. Why? Because A dash is A and B dash is B. Why? It is already given in the question that A and B are symmetric matrices. So I'll be able to write A dash as A, B dash as B, and A dash as A. So if I compare LHS and the RHS, again this is of the form A dash is equal to A. So I'll be able to confirm that the matrix that we get by multiplying ABA will be a symmetric matrix. Therefore, ABA is a symmetric matrix. Now let us move on to the next question. Now the next question is, for a 2 cross 2 matrix A that is equal to Aij, whose elements are given by Aij is equal to I by j, then the value of A12 is equal to. So in this question we are supposed to find the value of A12. See, basically we know that each and every element of a matrix can be represented in the form of Aij. So if I want to find the value of A12, I'll be replacing I with 1 and j with 2. So here they have already given us Aij is I divided by j. So if I consider I as 1 and j as 2, I'll be able to write this as 1 divided by 2. So the value of A12 is 1 divided by 2. Now let us move on to the next question. Now what is given in the next question? If the matrix x plus y, 2x plus z, x minus y, 2z plus w is equal to 4, 7, 0, 10, then the values of x, y, z and w are respectively. So in this question we are supposed to find the value of each and every variable we have, that is x, y, z and w. So for this, see, they have given us this matrix is equal to this matrix. So once we go with the equality of matrices, we will be able to write the corresponding elements as equal. Since it is given these two matrices as equal, I'll be able to write x plus y is equal to 4, x minus y is equal to 10, 2x plus z is equal to 7, and 2z plus w is equal to 10. So now x plus y is equal to 4 and x minus y is equal to 4 are in the form of simultaneous linear equations. So I'll be able to solve these two as x plus y plus 4, x minus y is equal to 0. So I'll be able to cancel plus y and minus y, and I'll be left with 2x that is equal to 4. So x will be equal to 4 divided by 2 and the value of x is 2. Now I can substitute the value of x is 2 in either of the equation so that I get the value of y. So let me substitute the value of x in first equation. So I'll be able to get it as x plus y is equal to 4. So this is 2 plus y is equal to 4. So y will be equal to 4 minus 2. So the value of y is 2. So to solve 2x plus z is equal to 7, we already have the value of 2 as x. So I'll be able to write 2 into 2 plus z, that will be equal to 7. So 2 2s are 4 plus z is equal to 7. So from here z will be equal to 7 minus 4. Therefore z will be equal to 3. So using the value of z, we'll be able to find the value of w also. So 2 times z plus w will be equal to 10. So I'll be replacing the value of z from here. So 2 into 3 plus w is equal to 10. 3 2s are 6 plus w is equal to 10. So the value of w will be 10 minus 6, that is equal to 4. So the value of x is 2, y is 2, z is 3 and w is 4. Now let us move on to our next question. So in this question they have given us if a is equal to a, b, b and a square is alpha, beta, beta, alpha, then the values of alpha and beta are respectively. So in this question we need to find the value of alpha and beta. So what is given? See, we already have a matrix A and a square is equal to alpha, beta, beta and alpha. So first thing, we will be multiplying a with a to get a square. So a square will be equal to b, ab, ba multiplied with ab, ba. So first I'll be considering the first row and the first column. So this will be equal to a into a is a square plus b into b is b square. For the next element, I'll be considering the first row and the second column. So that will be a into b plus b into a. For the third element again, I'll be able to write b into a plus a into b. Again, I'll be able to write, I'll be considering the second row and the second column. So I'll be able to write it as b into b is b square plus a into a is a square. So I'll be able to write this as a square plus b square. Now this is ab plus ba. See, we already know that for a scalar ab will be equal to ba. So I'll be able to write this as ab plus ab. So this becomes 2ab. In the same way, I'll be able to replace this whole thing by 2ab, and this b square plus a square can also be written as a square plus b square. Now they have given us that a square is alpha, beta, beta, alpha. So if I compare these two matrices, I'll be able to get the value of alpha as a square plus b square and the value of beta as 2ab. Now let us move on to the next question, that is 8th one. What is given in the 8th question is if the trace of the matrix A is 0, find the value of x. So the matrix A is given as x minus 1, 0, 2, 5, 3, x square minus 2, 4, 1, and the third row is minus 1, minus 2, x minus 3 and 1, and the last row is 2, 0, 4, x square minus 6. So what is given in this question is the trace of this matrix A is equal to 0. Now first thing, what do we mean by trace? See, we will be getting trace by adding all the diagonal elements. So what do we mean by trace? We get trace by getting the sum of all the diagonal elements. So if I want to find the trace, I should be adding x minus 1 plus x square minus 2, x minus 3 with x square minus 6. So the trace of matrix A will be equal to the sum of its diagonal elements. that is x minus 1 plus x square minus 2 plus x minus 3 plus x square minus 6. Now this value is given as 0. So this will be equal to 0. So let us add this and write the equation first. First let me write it in terms of x square. So this will be equal to 2x square plus 2x and this is 6, 7, 8, 9, 10, 11, 12. So minus 12 will be equal to 0. Now this is the equation that we have got. See, I'll be able to divide each and every term by 2. So if I divide each and every term by 2, I'll be getting x square plus x minus 6, that will be equal to 0. Now this equation is in the form of quadratic equation. So if we get the value of x, see, we can get the value of x by factorizing this equation. See, we can actually use many different methods for again calculating the value of x here. Since it is in the form of quadratic equation, one is we can actually factorize this equation, or it can also be found by using a formula minus b plus or minus root of b square minus 4ac divided by 2a. So here I'll be applying factorization to find the value of x. So here we will be able to get two values of x since it's a quadratic equation. So for applying the factorization, I'll be splitting up the middle term. So how do we split the middle term? I'll be considering the constant whatever is there, that is minus 6. And if I split this term, I should be able to get plus 1. So I'll be getting two factors, adding, I should be getting minus 6, and if I multiply I should get minus 6, and if I add I should get 1. So this will be equal to, so I'll be able to write the factors as 3 minus 2. So if I multiply 3 with minus 2, I'll be getting minus 6, and if I add 3 with minus 2, I'll be getting 1. So how will I be able to write this? X square plus 3x minus 2x minus 6, that will be equal to 0. So from the first two terms, I'll be taking x out, x plus 3, minus from the next two terms, I'll be taking minus 2 out, and will be left with x plus 3 again. So from these two terms, I'll be able to take out x plus 3, and what we are left with is x minus 2, and that will be equal to 0. So I'll be equating both the terms to zeros, that is x plus 3 will be equal to 0 and x minus 2 will also be equal to 0. So from here x is equal to minus 3 and x is equal to 2. So the value of x is minus 3, or the value of x can also be equal to 2. Now let us move on to the next question. So now what is given in the next question? If a is 3, 0, 0, 0, 3, 0, 0, 0, 3, then a square plus 3a equals. See, the options are also given. So the options are 18i3, 6a, 12a, or none of this. So what is given in the question is, matrix A is given. First we are supposed to find the value of a square plus 3a, and we should decide whether a square plus 3a is equal to one of the options. So first let us find the value of a square. So a square, see, we will get the value of a square by multiplying a with a. So this will be equal to 3, 0, 0, 0, 3, 0, 0, 0, 3 multiplied with 3, 0, 0, 0, 3, 0, 0, 0, 3. So we already know that for multiplying two matrices, the column of or the number of columns of the first matrix should be equal to the number of rows of the second matrix. So this is also a matrix of order 3 cross 3, and this is also a matrix of order 3 cross 3. So I'll be able to multiply these two. So for multiplying, first I'll be considering the first row and the first column. So what do we get? 3 3s are 9. 0 into 0 plus 0 into 0. Now this becomes our first term. Now for the second term, I'll be considering the first row multiplied with the second column. So this gives us 3 into 0, 0 again, 0 into 3, 0, 0 into 0 is again 0. So for the next element, I'll be considering the first row with the third column. That is 3 into 0 is 0. Again 0 into 0 is 0. Again 0 into 3 is also 0. So our third element will also be equal to 0. So for the next one, I'll be considering the second row with the first column. So 0 into 3, 0. Again 3 zeros are 0. Again 0 into 0 is 0. So here the third, for the next element, I'll be considering the second row with the second column. So even here 0 into 0 is 0, 3 3s are 9. Again 0 into 0, 0. So even for the next element, I'll be considering the second row and the third column. Even here we'll be getting the value of the element as 0. Why? Because 0 into 0 plus 3 into 0 plus 0 into 3 gives us 0. Now for the next element, I'll be considering the third row with the first column. So 3 into 0, 0, 0 multiplied with 0, again 0, 3 into 0 is 0. So for the next term, we'll be considering the third row and the second column. So 0 into 0 is again 0, 0 into 3 is 0, plus 3 into 0 is also 0. Now for the last element, we will be considering the third row with the third column. So 0 into 0, 0 plus 0 into 0 plus 3 3s are 9. So from here we got 9, 0 0, 0 9 0, 0 0 9 as a square. Now let us move on to the next question, that is 8th one. What is given in the 8th question is, if the trace of the matrix A is 0, find the value of x. So the matrix A is given as x minus 1, 0, 2, 5, 3, x square minus 2, 4, 1, and the third row is minus 1, minus 2, x minus 3 and 1, and the last row is 2, 0, 4, x square minus 6. So what is given in this question is, the trace of this matrix A is equal to 0. Now first thing, what do we mean by trace? See, we will be getting trace by adding all the diagonal elements. So what do we mean by trace? We get trace by getting the sum of all the diagonal elements. So if I want to find the trace, I should be adding x minus 1 plus x square minus 2, x minus 3 with x square minus 6. So the trace of matrix A will be equal to the sum of its diagonal elements, that is x minus 1 plus x square minus 2 plus x minus 3 plus x square minus 6. Now this value is given as 0, so this will be equal to 0. So let us add this and write the equation first. First let me write it in terms of x square. So this will be equal to 2x square plus 2x and this is 6, 7, 8, 9, 10, 11, 12. So minus 12 will be equal to 0. Now this is the equation that we have got. See, I'll be able to divide each and every term by 2. So if I divide each and every term by 2, I'll be getting x square plus x minus 6, that will be equal to 0. Now this equation is in the form of quadratic equation. So if we get the value of x, see, we can get the value of x by factorizing this equation. See, we can actually use many different methods for again calculating the value of x here. Since it is in the form of quadratic equation, one is we can actually factorize this equation, or it can also be found by using a formula minus b plus or minus root of b square minus 4ac divided by 2a. So here I'll be applying factorization to find the value of x. So here we will be able to get two values of x since it's a quadratic equation. So for applying the factorization, I'll be splitting up the middle term. So how do we split the middle term? I'll be considering the constant whatever is there, that is minus 6. And if I split this term, I should be able to get plus 1. So I'll be getting two factors, adding, I should be getting minus 6, and if I multiply I should get minus 6, and if I add I should get 1. So this will be equal to, so I'll be able to write the factors as 3 minus 2. So if I multiply 3 with minus 2, I'll be getting minus 6, and if I add 3 with minus 2, I'll be getting 1. So how will I be able to write this? X square plus 3x minus 2x minus 6, that will be equal to 0. So from the first two terms, I'll be taking x out, x plus 3, minus from the next two terms, I'll be taking minus 2 out, and will be left with x plus 3 again. So from these two terms, I'll be able to take out x plus 3, and what we are left with is x minus 2, and that will be equal to 0. So I'll be equating both the terms to zeros, that is x plus 3 will be equal to 0 and x minus 2 will also be equal to 0. So from here x is equal to minus 3 and x is equal to 2. So the value of x is minus 3, or the value of x can also be equal to 2. So now let us move on to our next question. If a is equal to 300, 030, 003, then a square plus 3a equals. So we are supposed to find a square plus 3 into a, and we are supposed to find the value of a square plus 3a. So in the question, see, they have specified that multiple answer or more than one answer is correct. So from the options, we may get the answer as one correct option, or more than one correct option can also be correct. So let us move on to the solution of this question. So first thing, we'll be multiplying a into a to get a square. So a square is 300, 030, 003 multiplied with 300, 030, 003. So first we'll be considering the first row and first column. 3 3s are 9, plus 0 into 0 is 0, again 0 into 0 is 0. So first row, second column, 3 zeros are 0, then 0 into 3 is 0, 0 into 0 is again 0. Now we'll be considering the first row and the third column. 3 zeros are 0, 0 into 0 plus 0 into 3 is again 0. Now for the next element, we'll be considering the second row and first column. 0 3s are 0. Again 3 into 0 is 0 plus 0 into 0 is 0. Now for the next element, second row with third column, 0 into 0 is 0 plus 3 3s are 9 plus 0 into 0 is 0. So I'll be considering second row with third column now. 0 into 0 is 0 plus 3 into 0 is again 0 plus 0 into 3 is 0. Now the third column, now we'll be considering the third row with first column. 0 into 0 plus 0 into 0 plus 3 into 0 is 0. So again third row with second column. 0 into 0 plus 0 into 3 is 0 plus 3 into 0 is again 0. So third row with third column, 0 into 0 is 0 plus 0 into 0 is 0 again plus 3 3s are 9. So this is our a square. So again we need to find the value of 3a also. So 3a, see, we'll be getting 3a by multiplying each and every element of a with 3. So that is 3 into 3, 0 0 0 3 0 0 0 3. So this will be again equal to 3 3s are 9, 0 0 0 3 3s are 9. Again this is 0 0 0, this is also 9. That is 9 0 0 0 9 0 0 0 9. Now we need to add a square plus 3a. A square plus 3a. So this gives us 9 plus 9, 18, 0 0 0, 9 plus 9, 18 again, 0 plus 0 is 0, so 0. This also gives us 0. This is 18. So first thing is we can take out 18 from here. So what will we be left with? 1 0 0 0 1 0 0 0 1. So this is 18I3. Why? Because this is the identity matrix of order 3 cross 3. Also, if I take out 6 from this matrix a square plus 3a, I'll be able to get 6 3s are. So this is 0 0, this is 0, 3 0, this is again 0 0, 3. See, again this matrix is our matrix A itself. So this is equal to 6 into A. So we have got two options, right? 18I3 and that is also equal to 6A. So here both options A and B are correct. Now the next question is, if 3a plus 4b dash is equal to 7 minus 10 17 0 6 31 and 2b minus 3a dash is minus 1 18 4 0 minus 5 minus 7. So then b is equal to, so in this question we are supposed to find the value of matrix B. See, whatever questions we have seen till now, we would have had something like 3a plus 4b is equal to some matrix and 2b minus 3a, that will again be equal to some matrix. But in this question they have given b dash and a dash also. So first thing that should strike to our mind is we should be considering the transpose of whole equation what is been given. Since I want the value of b, I'll be considering the first equation and I'll be considering the transpose of this first equation, that is whole transpose. So I'll be able to write this as 3a plus 4b dash the whole dash will be equal to, I'll be considering the transpose of this matrix also. So I'll be able to write this as 7 0 minus 10 6 17 31 the whole dash. So here I'll be able to get this as 3a dash plus 4b dash the whole dash. So this again is 7 minus 10 17 0 6 31. See, this can be written as 3a dash plus 4. See, b dash the whole dash is again b. So this is 7 0 minus 10 6 17 31. So I will just rearrange this equation in terms of this. That is, I'll be considering minus 3a dash plus 2b, that is again equal to minus 1 4 minus 5 18 0 minus 7. See, if I add these two equations, let me consider this as equation 1 and this as equation 2. Now if I add these two, plus 3a dash and minus 3a dash will get cancelled, plus I'll be able to write this as 6b, that is again equal to 7 minus 1 6 0 plus 18 18 minus 10 plus 4 is minus 6 6 plus 0 is 6 17 minus 5 is 12 31 minus 7 is 24. So from here I got 6b as 6 18 minus 6 6 12 24. Now if I want the value of b, I'll be able to take this as 1 divided by 6 multiplied with 6 18 minus 6 6 12 24. So I'll be dividing each and every element of this matrix with b, with 6. So I'll be able to get this as 1, 6 3s are 18, again 6 1s are 6, this is 1, 6 2s are 6 4s are 24. So the value of b is 1 3 minus 1 1 2 4. So our next question is, for the matrix A 3 2 1 1, find the numbers a and b such that a square plus of a into a plus b into I is equal to 0. See, we can actually solve this using two different methods. One is taking a square first, then multiplying matrix A with A and considering the identity matrix 1 0 0 1 and multiplying that with B, adding everything, and that will be equal to 0, and then comparing LHS and RHS and getting the values of A and B. So we actually have another shortcut where if a square plus a into a plus b into I is equal to 0, then we will be able to write any matrix A as a square minus trace of matrix A multiplied with A plus determinant of matrix A multiplied with I is equal to 0. So we will be using this equation to find the value of A and B here. That is a square minus trace of A multiplied with A plus determinant of A into I is equal to 0. So first let us find the trace of matrix A. Now how do we get the trace? We will be taking the sum of the diagonal elements. So here the diagonal elements are 3 and 1. So the trace of A will be equal to 3 plus 1, that is 4. So how do we find the determinant? So determinant A is 3, 2, 1, 1. So this will be equal to 3 into 1 minus 1 into 2. So this is equal to 3 minus 2, that is equal to 1. So how will I be able to write this equation as A square as it is? I have got the value of trace. Trace is 4. So 4 multiplied with A plus, what is the value of determinant? Determinant is 1 multiplied with I is equal to 0. Now we need to compare this equation with the given equation, that is A square plus A into A plus BI. So comparing with A square plus A into A plus B into I is equal to 0. So if I compare this and this, I'll be able to get the value of A as minus 4 and the value of B as 1. So here the value of A is minus 4 and B is 1. So the next question is, if A is equal to 1 by pi multiplied with sine inverse of pi x, tan inverse of x divided by pi, sine inverse of x divided by pi, cot inverse of pi x, and B is given as 1 divided by pi multiplied with minus cos inverse pi x, tan inverse x by pi, sine inverse x by pi, minus tan inverse pi into x, then A minus B is equal to. So here we need to subtract these two matrices and we should tell what is the value of A minus B. So A minus B will be equal to, we'll be subtracting these two matrices. So we have 1 by pi common in these two matrices. So I'll be writing 1 by pi outside itself. So I'll be able to subtract these two as sine inverse pi x, sine inverse pi x minus of, this is minus cos inverse pi x. The second term is tan inverse x divided by pi minus tan inverse x divided by pi. Again the third term is sine inverse x by pi minus sine inverse x by pi. Fourth term will be cot inverse pi x minus of minus tan inverse pi x. Now this is the matrix that we have got by subtracting the two given matrices. So this will be again equal to 1 divided by pi. So sine inverse of pi x minus of minus plus cos inverse of pi x. This tan and this tan will get cancelled. So we got 0. In the same way, sine inverse pi x minus sine inverse pi x gives us 0. So this becomes again cot inverse of pi x plus tan inverse of pi x. So we already know that sine inverse of A plus cos inverse of A will be equal to pi divided by 2. In the same way, cot inverse of A plus tan inverse of A is also equal to pi divided by 2. So I'll be able to replace sin inverse pi x plus cos inverse pi x by pi by 2. This will be equal to 0. This again will be equal to 0, and cot inverse pi x plus tan inverse pi x can be replaced with pi divided by 2. Now if I take out pi, by 2, I'll be able to get 1, 0, 0, 1. So pi and pi will get cancelled. 1 divided by 2 and this is of the form identity matrix. So I'll be able to write this as 1 by 2 I. So A minus B is equal to 1 by 2 I is the answer here.